All right, for example 5, find the circumference of the following arc. Okay, so first of all, let me give you a little vocabulary here so we know what things are. All right, so I'm looking at a part of a circle. It's got this inside angle here, 135. The arc they're talking about starts here and is the edge of this circle all the way around to there. That's what an arc is. An arc is a portion of the circle's circumference, but it's not the whole circumference. Okay. Can anybody tell me how many degrees there are in a whole circle?
360.
Whole circle has 360, right?
Why 360?
I'll tell you why. Hang on a second. All right. So if I chop a circle in half. If I go right here and chop it in half, how many degrees in the line?
180.
180, right? 180 line. So 180 above and 180 below makes 360 altogether.
You said light 360.
Oh, live 360. I thought that said Y. I thought you said Y 360. I didn't realize we were doing advertisements for products. So I don't know if YouTube's probably going to ban this video. All right. I hold no licenses for any products on the internet, so hopefully they don't ban my video because it's hidden. All right. Anyway, but you can see here that we have a portion of a circumference, and the whole circle has 360 degrees. So if I take a look, this is about circumference. I know circumference of a circle equals 2 pi times the radius. Now notice I left a little gap here. Make sure you leave that on your paper. So there's my whole circle circumference, right? If I started here, went all the way around the circle, I would go exactly 2 pi times 10 centimeters around this circle. The portion of the circle we're focusing on only has a degree measure of 135. So the part of the circle we're dealing with is the part 135 divided by the whole 360. This is always 360, and this is whatever this angle is. All right, so we're dealing with a circular arc, a portion of the entire circumference. The inside angle over 360. Now if we go back a couple examples here, this right here, if we were to draw in the center like this, makes a right angle. 90 divided by 360 reduces to 1/4. So it's basically the same formula used there, but now we don't have a 90-degree angle. We have a 135-degree angle. But it's the same idea. We take the whole circumference times the portion we're dealing with. That's how we handle that. So at this point, everything I need is right there. It's just a matter of punching it in the calculator. Now, obviously things reduce if I feel like reducing it. But again, my calculator knows how to evaluate this without reducing, so I might as well just go with that. So parentheses, or not even parentheses, I'm just going to do 135 divided by 360 times 2 pi times 10. Again, 135 over 360. Once I hit times, now it's throwing it back on top. It's multiplying again. Hit equals, and it's 23.56. 19449. 23.56. 19449 centimeters. Okay, it says round your answer to 2 significant digits. All right, so if I go 2 digits, 23, right? But the next digit's a 5. So what do I do to the 3?
Make it a 4.
Make it a 4. So the circumference of this thing will be 24 centimeters. I usually use the letter C to represent the length of a sector, or sorry, length of a arc, because it's part of the circumference. Right? But again, from here to here should be about 24 centimeters. All the way around the thing is much more than 24, right? Because again, we took this times that fraction to get 24.